Hi everyone. Our next topic is jet parameters. Wait a second. So, which is also called as open circuit impedance parameters. Open circuit impedance parameters. Okay, this is the first one. So first you can take two-port network standard model. That is so this is port one, and this is port two, and this is your network, and one dash, two dash, and this is V1, and here the variable is I1, and here V2, and the variable is I2. So port 1 variables are V1 comma I1, and port 2 variables are V2 comma I2. Okay, this is your two-port network standard model. So in this jet parameters, so V1 comma V2, V1 comma V2, and I1 comma I2. Okay, so this V1 comma V2 are dependent variables. Okay, dependent variables. How you decide these voltage variables are dependent variables, that we will discuss in later part. Okay, and I1 I2 are independent variables. Independent variables. And I already told you Z parameters is nothing but Theven, series network. Okay, series network. Series network in the sense what? Thevenin's network, right? Thevenin's network. Okay, just you remember these two things. Okay? Get parameters is nothing but which is applicable for series type of networks. Otherwise, we can derive from series networks. Okay, and in order to evaluate individual responses for a given series network, you have to apply this Z parameters. Okay, so even Thevenin's equivalent model is there, so you need to evaluate the individual responses, then you can go with Z parameters. That is the suitable one. Not only Z parameters, you can use H parameters, you can use Y parameters, you can use ABCD, you can use Z parameters, you can use inverse transmission parameters also. Okay, but the best suitable case is Z parameters. Okay, so anyway, so now, so here V1 V2 V1 V2 are called as dependent variables, and I1 I2 are called as independent variables. Okay, now, so here if you take this as a two-port network. Okay, so in between, in this these two ports, so I will take one particular network like resistors. Okay, so this is, I will take one example. Okay, so this is our network, right? This is our network part. Okay, and this is port 1, and this is port 2, and here V2, and here V1, and this one is I1, and this one is I2. That means from port 2 we are getting I1 current, from port 1 we are getting I1 current, from port 2 we are getting I2 amount of current, and both the currents can be flowing through this particular, here we are expecting I1 current, here we are expecting I2 current. This I1 I2 both the currents are can flow through this particular resistor. Now at this resistor we have the current I1 plus I2, right? That means, for example, if I am applying a KVL expression for this particular loop, okay, KVL expression for this particular loop, what happened? So first voltage V1, and next, in case if any resistor, if we have a resistor at this place, so you can take the drop across that particular resistor. After that, you can take this particular resistor, right? Otherwise, I will take one resistor here also, no problem. Okay, this is one resistor. That means here we have certain drop, right? And here also we have certain, if I am applying KVL, so minus V1 plus I1 into this particular resistance, whatever the resistance, I don't know, just I am taking Z, okay. And next, this particular, so I think this is, I'm taking Z1, and this I will take, uh, otherwise you can take, this is, this resistor is belongs to port 1, right? This resistor purely related to port 1, so that I am taking port to 1 impedance Z11. I am taking 1 in the sense what? Always remember, so this is Z parameters. So here we are using suffix. In the suffix we have two parameters. For example, if I am taking 1 1, right? So in this Z11, so this one is considered as input parameter, and this one is considered as output parameter, right? This one is considered as input parameter, this one is considered as output parameter. So here Z11 is nothing but what? The impedance is collected from input only, right? That means this one is nothing but related to what? That means input at 1, output also at 1, right? Z11 in the sense what? Input at first terminal, otherwise port to 1, okay, and output also at port to 1 only, okay. That means you are sending the impedance from this port and you can collect it at the port to 1 only, okay. So that is the meaning of Z11. For example, if I am taking Z12, okay, that means this is input and this one is output, right? Now what you will get, that means the impedance can be transferred from input to output, right? The input impedance, otherwise impedance, you can take impedance, the impedance can be transferred from port to 2 to port to 1. That means input to output impedance transformation. So that will indicated with Z12, right? That will indicated with Z12 notation, okay. So that is the mean. For example, if I am taking Z21, so this is your input and this is your output. That means a 1 to 2 transformation, okay, impedance transformation from port to 1 to port 2. That is the meaning, right? So now, okay, so here you are getting Z11. After that, you can take Z12, and this combination of these two currents, right? That means I1 plus I2, like that. You will get algebraic sum of voltage equals to 0. From this, you can able to write V1 equals to what? So otherwise, you can, okay. So you may get confused with this equation. So certain amount of I2 current you can take, okay, no problem. Okay, just you can leave this expression, okay. My intention is here, so that means this V1, this voltage V1 is a function of this I1 current as well as I2 current. That that is what my intention, right? This V1 is a function of I1 current as well as I2 current. That means here I am writing V1 equals to function of I1 current and I2 current, right? In the similar case, if you observe this V2, so if you write the expression for this particular loop, that is involved in two variables, I1 as well as I2, right? That means what? The V2 depends on, I2 current as well as for example, if I am writing the expression for this particular loop, that mine the V2 equals to this I2 into this particular impedance and I1 plus I2 into this particular impedance. That is the equation, right? That means what? That entire V2 that depends on I1 and I2 variables or not. That means V2 also a function of I1 comma I2, right? v1 is a function of I1 comma I2, and v2 also function of I1 and I2. Okay, you can ignore the what impedance values. Okay, certain impedance here we have, and certain impedance here also we have, certain impedance here also we have. Okay, that you can ignore first. Okay, but if you take the expression of this particular loop, that the v1 variable depends on I1 as well as I2 current, and here v2 also depends on I1 and I2 variables. From this context, that v1 depends on I by I2 and v2 also depends on I1 I2, means these v1 and v2 are what, dependent variables or not. That's why I'm indicating v1 and v2 dependent variables. And in the case of I1 I2, so v1 v2 depends on I1 I2, but I1 I2 not depends on v1 v2 and any other factors also, right? So I1 I2 are not depending on any other factors, so that's why I'm taking I1 I2 are independent variables. Okay, that is the meaning. Okay, and now so here I am writing, so v1 v2 is a function of I1 I2. That's why these are dependent variables, and these are independent variables. Okay, and now here v1 equals to z11 into I1 and z12 into I2, and v2 equals to, that means 1 impedance and 1 to 2 impedance. Okay, so and the next case I am taking from port 2 z21 into I1 plus z22 into I2. So these are the z parameters. So this is equation number 1 and this one is equation number 2 from 1 and 2. From 1 and 2, that means we can make a matrix form, that is v1 v2 equals to, so these all are z parameters, z11 z12 and z21 and z22, these all are z parameters. So you can take z parameter matrix here, so that is z11 z12 z21 and z22, and which is multiplied with the independent variables, that is I1 comma I2. This is z parameter matrix. Okay, this one. Okay, z parameter matrix. Okay, so now otherwise, okay, so here v1 equals to and v2 equals to z11 I1 z12 I2 z21 I1 z22 I2. These are the two expressions. Okay, now sorry, in the previous, wait a second, so this is z suffix xy, right? In this two things, so uh, this one we can consider as output, right? This one we can consider as input. Okay, so now I think previously సేమ్ చెప్పాను, రివర్స్ చెప్పాను, ఒకసారి క్రాస్ చెక్ చేయండి. ఐ థింక్ నా దగ్గర లేదు, అది ఎరేస్ చేశాను. ఐ థింక్ ఒకసారి చెక్ చేయండి, ఇది నేను ఆర్డర్ కరెక్టే చెప్పాను. దిస్ వేరియబుల్ ఈజ్ రైట్ సైడ్ వేరియబుల్ ఈజ్ ఇన్పుట్ అండ్ లెఫ్ట్ సైడ్ వేరియబుల్ ఈజ్ అవుట్పుట్, రైట్? సో దట్ యూ హ్యావ్ టు రిమెంబర్. ఓకే, ఈ సఫిక్స్లో మీకు ఏవైతే టూ పార్ట్స్ ఉన్నాయో అందులో రైట్ సైడ్ పార్ట్ వచ్చేసి ఇన్పుట్గా కన్సిడర్ చేస్తాం అండ్ లెఫ్ట్ సైడ్ పార్ట్ వచ్చేసి అవుట్పుట్గా కన్సిడర్ చేస్తాం. దట్ యూ హ్యావ్ టు రిమెంబర్. ఓకే, అండ్ నౌ for example, so I need to evaluate z parameters. I need to evaluate z parameters. So here these are the v1 expression and v2 expression. From these two expressions I need to evaluate z parameters is nothing but what? z11, z12, z21, z22. These are the z parameters, right? I need to evaluate those z parameters. For example, if I want to evaluate this z11, if I want to evaluate this z11, what I have to do? From this expression, if I want to evaluate z11, what I do? Definitely I will make I2 0. Then only I can evaluate z11. Otherwise, I cannot evaluate, right? If I make I2 equal 0, then only I can able to find out the z11 parameter. Otherwise, I cannot evaluate this z1. For that, I need to make it as I2 is I2. That means you can make it as 0. Okay, that but in case if I make I2 equals to 0, is there any other parameter we need to evaluate? That means is there another possibility to get the z parameters? That means by making I2 equal 0, you can evaluate z21 also, right? If I make I2 equal 0, same thing you can substitute here also, then you can evaluate z21 also, right? By making I2 equal 0, we can able to find out two z parameters. One is z11, other one is z21. In the similar context, if I make I1 equals to 0, if I make I1 equals to 0, from these two expressions, I can evaluate z12 as well as z22. Okay, so first I will take, wait a second. Okay. By making I2 equals to 0, by making I2 equals to 0, so here I am getting z11 equals to, if I make I2 equals 0, I will get only this expression. So from this expression, z11 equals to v1 by I1. Okay, this is one possibility. If I am looking into this second equation, if I make I2 equal 0, I can evaluate z21 also. So that I will take z21 also here. Z21 equals to what? V2 by I1. This is clear. Now, after that, I will go for I1 equals to 0. Okay, if I make I1 equals to 0, I can evaluate Z12 as well as Z22. So now, Z12 equals to, so V1 by, this is only, right? Z12 I2, that equals to V1, right? So from this, Z12 equals to V1 by I2. And in the same thing, you can apply to the second equation. V2 equals to what? Z22 into I2. So from that, Z22 equals to V2 by I2, right? So this is possible only when I2 equals to 0. This is possible only when I2 equals 0. This is possible only when I1 equals 0. This is possible only I1 equals to 0. Now, here if you observe, I already told you in this suffix, this right one is we can call it as input and the left one is we can call it as output. So if you observe this, generally impedance is nothing but what, according to Ohm's law, V equals to what? IR. So R equals to what? V by I, right? So but in the circuit we have so many resistances, then we can call it as impedance, that Z equals to V by I, right? This is according to Ohm's law, Z equals to what? V by I. Here we are calculating only impedances, right? Z11, Z21, Z12, Z22, all are impedances means. So according to Ohm's law, we are getting numerator term voltage and denominator term should be current. That is from Ohm's law, right? Impedance means obviously numerator term will indicate it with voltage, denominator term will indicate it with current only. But where you have to find out is, that is the different scenario, right? If I am calculating port 1, if I am calculating at port 2, if I am calculating port 1 to 2, otherwise if I am calculating port 2 to port 1, that is the different aspect, right? But ultimately what I can conclude, if you want to evaluate impedance at any place, okay, but the numerator term should be voltage and the denominator should be current, right? So that is the conclusion, right? So now if you observe Z11, in this 11, this part is what input, right? And this part is what output. Okay, so I am considering output at port 1 and input also at port 1. That means both the input output both are at consider port 1 only, right? Both are considered at port 1 only. So that is the meaning of Z1, right? Input is at 1 and output also is at port 1 only. So that is belongs to port 1 related impedance. That Z11 is nothing but what? That is port 1 related impedance. For example, if you observe this network, the standard model, so input I am collecting at port 1 terminal. Okay, output also I am collecting at port 1 terminal. So that is purely related to port 1 parameter, right? So I'm connecting first V1, right? And after that I'm connecting I1 at port 1, right? Now I'm taking Z11, that is V1 by I1, right? That means this impedance Z11 impedance is purely related to port 1. That 11 indicates port 1 related impedance. Okay, so now, so here, so that's why, so we can call it as this entire Z11 is nothing but a driving point impedance, driving point impedance. Otherwise we can call it as open circuit input impedance, open circuit input impedance. So that is the meaning of Z1. In the same way, you can verify this Z21 also. Z21 is nothing but input at port 1, right? I am starting at port 1 and I am ending with port 2. That means output at port 2, right? This left side uh, thing is called as output. This right side thing is called as input according to our notation, right? So that means the impedance can be transferred from port to 1 to port to 2, right? Why I am considering port 1 to port 2 means always we can travel from input to output, right? Always we can travel from input to output. Here the input is nothing but what? Port 1, and output is should be what? A port 2. That means that impedance can be transferred to port 1 to port 2. That is the meaning, right? That is the meaning. So that's why I will name it as transfer impedance. Okay, whether it is 1 to 2 transfer or 2 to 1 transfer, that is the different, but ultimately we can conclude that that is the transfer impedance, right? So from one port to another port the impedance can be transferred, so that's why we can call it as transfer impedance. Here I am taking transfer impedance. Some textbooks they are refer this transformation from port 1 to port 2. Okay, this transformation is from port 1 to port 2, so that's why they are called forward transfer impedance. Forward transfer impedance. Forward transfer impedance. So you can use in a conclusion way, you can use transfer impedance. If you want to specify the ports also, then you can call it as forward transfer. Forward transfer impedance means that impedance can be transferred from input port to output port. In case of output to input, you can call it as a reverse transfer impedance. Okay, so if you observe this Z12, the second port is what? Input. Okay, the first port is what? I will consider this first port as in output, right? That means what? I'm always traveling from input to output, but here input equals to what? Port 2, and output equals to what? Port 1. That means impedance can be transferred from port 2 to port 1. In a in a summarized way we can call it as transfer impedance, right? In a summarized way we can call it as transfer impedance, but if you want to specify that means from where to where it can be transferred, so in that context I am using a reverse transfer impedance. In that context I am using reverse transfer impedance. Reverse transfer impedance, right? Why? Because which is moving from uh, port 2 to port 1. Port 2 I am considering as input, and port 2 1 I am considering as output. So that's why generally forward nature means port 1 to port 2. Reverse manner is nothing but what? Port 2 to port 1. Okay. So if you consider port 2 as input or output, that is a different aspect. But what direction you can move, that is important. 1 to 2, that is the forward. 2 to 1, that is nothing but reverse, right? So this is third parameter. When it comes to fourth parameter, which is also similar to Z1 only. Why? Because I'm calculating V2 at output port, and I'm calculating I2 also at input port. That's why this is completely related to port 2 related impedance. So I can call it as a driving point impedance. Otherwise, we can call it as a open circuit output impedance, right? Open circuit output impedance. Okay. So Z11 is nothing but what? Open circuit input impedance. Z22 is nothing but what? Open circuit output impedance. Z21 is nothing but what? Transfer impedance. That is from 1 to 2. So that's why we can call it as forward transfer impedance. And Z12, that is nothing but transfer impedance, which is also called as reverse transfer impedance. Always remember, so Z21 means, so in the numerator term we have a second port related variable. The denominator we have port 1 related variable. Here 1 related to input side parameter, and 2 which are related to output side parameter. So that's why, so this expression we can conclude that output by input. Okay, output by input, always, not only this, and in everywhere you can consider output by input. Output variable is what? From this Z21 V2. Okay, and input related variable is what? I1. So Z always mentioned in V by I format, but here uh, which port related voltage variable you have to consider, that is the matter, right? So I am considering voltage only, but port 1 related voltage variable or port 2 related voltage variable, that is important. So from this Z21, output is nothing but which are related to port 2 related parameter, right? So that's why I'm taking port 2 related voltage only. One is nothing but which is related to input, so that's why in the denominator, ultimately denominator having I only, but port 1I or port 2I, that is the important. So from this Z21, port 1 related I1 I have to consider, right? So in that way also you can move. So for example, if I am taking Z12, so what is the formula of Z12 means? So V1 by I2. Already you know V by I. Okay, Z means V by I only. But here what you can consider? First 1, and here this is output, right? And this is input, right? So first you can take output, after that you can take input, I2, like that. Okay, for example, Z22, so you know V by I only, but both are related to port 2, so that you can take 2 and 2, V2 by I2, like that. Okay, this is about Z parameters. Okay, so and so we have two conditions for this Z parameters. So one is symmetry condition. I already explained symmetry condition as well as reciprocity condition. The first one, symmetry condition. So for Z parameters, symmetry condition is nothing but Z11 equals to Z22. Then it satisfies the symmetry condition. Okay. And for reciprocity, if I am taking Z12 equals to Z21, Z12 equals Z21, then it is called as a reciprocal network. Otherwise, which follows the reciprocity condition. These are the conditions about Z parameters. Okay, for Z parameters, Z11 equals Z22, then it follows the symmetry condition. If Z12 equals Z21, then it follows the reciprocity condition. So first I will so proofs are not required, but anyway I will go with first symmetry condition proof. Okay, the condition is what? Z11 equals to Z22. Okay, right? First you can take the expression. So v1 equals to z11 I1 plus z22, sorry, z12 I2, and next v2 equals to what, z21 I1 plus z22 I2. These are the two expressions. So if I want to evaluate z11, so what I need z11 value and z22 value. After that I will make it as both are equal. That is our symmetry condition, right? So first I will find out z11 from this expression. Okay, so what is the z1 value? If I want to find out z11, definitely I will make it as I2 equals to 0. So z11 equals to what, v1 by I1 when I2 equals to 0, and z22 equals to what, v2 by I2 only when I1 equals to 0. So now, but according to our symmetry condition, according to our symmetry definition, if I am observing this two port network from both the ends, port 1 and port 2, from both the ends, if I observe this particular network, if it is same, then which is called a symmetrical network. That is the definition, right? Otherwise, if you divide this entire network into two equal halves, so one half is mirror image of the second half, then it is called a symmetry. These are the definitions, right? For example, here I am taking v1 and I1, and in the port 2 I am taking v2 I2, right? If I am observing at both the ends, from port 1 end and port 2 end, if both are same, then the network is symmetry. So for example, if you observing from port to one end, so what you can observe, v1 voltage source and I1 current you can observe, right? From port 2, if you observe, you can get the variables like v2 comma I2. So in this context, if both the observations are same or not, that you can check. Okay, that you have to check. So we, in the port 1 we have v1 I2, from port 2 end you can get v2 I2. So both the observations are different. So in that context, that will not follow the symmetry condition, right? So in order to, that means that is not symmetrical network, not condition, that is not symmetrical network. Okay, so if I want if that network follows the symmetrical, okay, so if you want to define that as a symmetrical network, definitely both the ends your observation should be same. Okay, so in order to follow the symmetrical type network, so both the observation should be same. In that context, I will take v1 equals to v2 equals to v, and I1 equals to I2 equals to I. Now the port 1 observations v comma I, and port 2 observation also v comma I. Now both the ends the observations are same, so that the given network is what, symmetrical network. A symmetrical network. So from this expression, so from this this is equation number 1. Okay, so from this expression you can substitute the v1 v2 values and I1 I2 values in these expression. This is second expression and this one is third expression. Okay, now you can take from 1 comma 2 comma 3, so z11 equals to what, v by I, and z22 also v by I. Now if you observe these two expressions, what you will get, z11 equals to z22, that means both are v by I equals to v by I. So now our condition is satisfied or not, verified or not. This is your proof. Okay, this is your symmetry condition proof. Okay, like that you can apply all the parameters. Okay, that means y parameters, h parameter, g parameters, a b c d, and inverse transmission parameter. For all the parameters this proof is same. Okay, like that you can follow. Okay, and in the next case I will take second condition, that is reciprocity condition, right? Reciprocity condition, so that is z12 equals to z21. This is our condition. First you can take z parameters, that is v1 equals to z11 into I1 plus z12 into I2, and v2 equals to z21 I1 plus z22 I2. So these are the expressions, right? So now this is expression number 1, this is equation number 2, right? Now So for example, if I am taking this as a two-port network, okay. So here I will take S minus V1, and this is I1 current. This is your network, and this is plus or minus V2, and this is I2. Okay. So now, so this is port 1, and this is your port 2, and 1 dash terminals, right? And 2 dash terminal. So this is our two-port network. So first you can make it as case 1, V2 equals to 0. Okay, first you can make it as V2 equals to 0. Okay, that means this is 0. This 0 means which can act as short circuit, right? If it that means 2 dash connected as short circuit, then you will get V2 equals to 0. Okay, that is our assumption. So based on this entire thing should be considered as one network or not. That means current can be start at this one terminal, and it can be passing through a network and coming to this point, and after that it can be moved to this short circuit, and after that it can return to again 1 dash terminal, right? That means this entire thing should be considered one particular circuit or not. So in this context, this, for example, if I am taking this equation again, so V1 equals to Z11 I1 plus Z12 I2, and next by making V2 equals 0, 0 equals to Z21 I1 plus Z22 I2. But if you observe, this I1 current is moving like this, okay? That means this is one dash terminal. So I1 starting at one terminal, like that it is moving. This is I1. In between we have a network, so that can be following through network also, that can be flowing through network also, and here also I will get I1, here also I1, here also I1, and like that the current will be flowing, right? Like that current will be flowing. But when coming to this I2 part, so I2 is what, reversed or not? I2 is in reverse direction or not? In that context, you can take minus I2 in these expressions, right? You can take minus I2 in these expressions. Now you will get V1 equals to Z11 I1 minus Z12 I2, and 0 equals to Z21 I1 minus Z22 I2. Okay. Now from this expression you can write I1 value. So I1 equals to what? Z22 by Z21 into I2. So this is your I1 value. Now this I1 value you can substitute in equation number 1, right? That means this V1 equals to Z11 into I1 plus Z12 into I2, right? So in this expression you should substitute this I1 value, right? You can substitute this I1 value. Wait a second. Okay, so here I1 equals to what you will get, Z22 by Z21 into I2. So this is your I1 value. Now you can substitute this in V1 equals to Z11 I1 minus Z12 I2. So now V1 equals to Z11, where I1 equals to what? This entire thing. You can substitute here. So you will get Z22, Z21 into I2 minus Z12 into I2. So from this entire expression, you can take common factor as I2. Then you will get V1 equals to I2 into Z11 into Z22 by Z21 minus Z12. To simplify this expression, so you will get V1 equals to I2 into Z11 into Z22 minus Z12 into Z21 by Z21, right? So this is your expression, and this entire thing you should assume as delta Z. Okay, delta Z equals to what? Z11 into Z22 minus Z12 into Z21. Now V1 by I2 equals to what? Delta Z by Z21. You can write in this way also. I2 by V1 equals to what? Z21 by delta Z. So this is our expression. So from this, I2 by V1 is nothing but what? I21, I2 by V1. That means what? Z. Okay, just you can okay, you can leave it here only. Then you can go for case 2 condition. Just you can make it as this is equation number 3, right? This is equation number 3. Now you can go for case 2. Okay, in this case 2, in this case 2, so in the previous case, what we have to do, we have to make it as v2 equals 0, but now in this case 2, we can make it as v1 equals to 0. So v1 equals, this is our 2-port network. Okay, and so here oh, wait a second, this is v1 and this one is I1, this is v2 and this one is I2, but this time I will make it as v1 equals to 0. This will become 0, that means this is short circuited, and this time we will consider minus I1 amount of current. Already we know the expressions, that is v1 equals to what? Z11 into I1 plus Z12 into I2, but according to our condition, V1 should be 0. That means this will make it as 0. Now V2 equals to what? Z21 into I1 plus Z22 into I2, but this I1 should be replaced with minus I1. Okay, now you will get 0 equals to minus Z11 I1 plus Z12 I2, and V2 equals to minus Z21 I1 plus Z22 I2. These are the expressions. So from this equation, we can find out I2 equals what? Z11 by Z12 into I1, right? So this is I2. Now you can substitute this I2 value in this expression. So what you will get? So V2 equals to minus Z21 I1 plus Z22 into, so here I2 equals what? Z11 by Z12 into I1. So this is, that means entire expression is converted into I1 format. Now you can take I1 as a common factor, then you will get I1 into Z11 into Z22 minus Z12 into Z21 by Z12. So this is our expression, right? So from this already we know delta Z equals to what? Z11 into Z22 minus Z12 into Z2. But if you observe this one, Z11 into Z22 minus Z, so this you can represent with the delta Z also. Now what you will get? So V2 by I1, V2 by I1. So V2 by I1 equals to delta Z by Z12. Now you can make it as I1 by V2 equals to Z12 by delta Z. This is expression number 4, right? Now you can take 3 and 4 expressions. Okay, so this is third expression, right? I2 by V1 equals to Z21 by delta Z, right? So now you can take, wait a second, what is this? I2 by V1, right? I2 by V1 equals to Z21 by delta Z. This is equation number 3. Next, fourth expression, that is I1 by V2. I1 by V2, that equals to Z12 by delta Z. Z12 by delta Z. This is equation number 4, right? from 3 and 4. From 3 and 4, you will get I2 by V1 equals to I1 by V2. Then it follows the reciprocity condition. Then it follows the reciprocity condition. Right? Already we know the reciprocity condition statement, right? In that statement, I will make it as I1 by V1 equals to I2 by V2. But I already explained about this I1 by V1 and I2 by V2 related information, right? So ఆల్రెడీ మీకు చెప్పాను. ఓకే, మీరు చూడాల్సింది ఏంటి, రేషియో బిట్వీన్ రెస్పాన్స్ టు ఎగ్జైటేషన్, response to excitation, but not the terminals. Okay, response to, that means output to input, output to input, అవుట్పుట్ టు ఇన్పుట్ రేషియో మాత్రమే మీరు చూడండి. టర్మినల్స్ ఏంటనేది మీకు అనవసరం. ఓకే, అంటే నేను ఫస్ట్ టర్మినల్ దగ్గర తీసుకుంటున్నాను, సెకండ్ టర్మినల్స్ దగ్గర తీసుకుంటున్నా, థర్డ్ టర్మినల్, దట్ ఈస్ యూ కెన్ ఇగ్నోర్. ఓకే, సో యూ కెన్ ఫోకస్ ఆన్ output variable, input variable, that is enough. Here the output variable is what? Current, whether it is port 1 or port 2 or port 3 or port 4, whatever the port, just you can ignore that port number. Okay, you can focus on output variable and you can focus on input variable only. మీకు ఏంటంటే మీకు స్టేట్మెంట్ I1 by V1 I2 by V2 అని చెప్పేసి గుర్తుంటుంది, మీరు దాన్నే ఫాలో అవుతారు. బట్ మీరు ఫాలో అవ్వాల్సిందే ఆ స్టేట్మెంట్ని కాదండి, డెఫినేషన్ మీరు ఫాలో అవ్వండి. ఓకే, రెస్పాన్స్ టు ఎగ్జైటేషన్ రేషియో విల్ గివ్స్ ది రెసిప్రొసిటీ థీరం. ఆ రెస్పాన్స్ వేరియబుల్ అనేది ఏ పోర్ట్ దగ్గరైనా కన్సిడర్ చేయొచ్చు. బట్ ఈ కాంటెక్స్ట్లో I2 అంటే సెకండ్ పోర్ట్ దగ్గర మనకి కరెంట్ అనేది కన్సిడర్ చేస్తున్నారు అవుట్పుట్ వేరియబుల్గా. ఫస్ట్ పోర్ట్ దగ్గర వోల్టేజ్ వచ్చేసి ఇన్పుట్ వేరియబుల్గా కన్సిడర్ చేస్తున్నారు. ఓకే, then also it follows the reciprocity condition, right? So that I will make it as I2 by V1 equals to I1 by V2. మనకి రెసిప్రొసిటీ కండిషన్లో ఏంటి, సోర్స్ అండ్ లోడ్ని ఇంటర్చేంజ్ చేసేసి సెకండ్ పారామీటర్స్ని కన్సిడర్ చేస్తారు. ఆ టైంలో మనం I2 V2గా తీసేసుకుంటాం. బట్ ఇక్కడ మనకి పోర్ట్ 1 పోర్ట్ 2 ఎట్ ఎ టైం కన్సిడర్ చేస్తున్నాం కాబట్టి I2 by V1 ఈక్వల్స్ టు I1 by V2 అయితే అది రెసిప్రోకల్ నెట్వర్క్గా బిహేవ్ చేస్తుంది. బట్ I2 by V1 ఈక్వల్స్ టు I1 by V2 అవ్వాలి అని అంటే ఇక్కడ మనకి Z1 ఈక్వల్స్ టు Z12 ఈక్వల్స్ టు Z21 అయితేనే మనకి అది పాసిబుల్ అవుతుంది, రైట్? అకార్డింగ్ టు దిస్, okay, I2 by V1 equals to what? Z2 by delta Z, right? This one. Yes, you can place here Z21 by delta Z, which is equals to I1 by V2. So I1 by V2 is nothing but this one, Z12 by delta Z. Okay, now you can cancel both each other. Then what you will get? Z12 equals to Z21. So if Z12 equals to Z21, then the given network should be follows the reciprocity condition. That is the meaning of Z12 equals to Z21, right? So this is about the reciprocity condition for Z parameters proof, right? So what is the symmetry condition? Z11 equals to Z22, and then it follows the given network follows the symmetrical network, otherwise symmetry condition. And if Z12 equals to Z21, then the given network follows the reciprocity condition, right? Then it's called as a reciprocal network. Okay, this is about Z parameters. And one important thing, so these symmetry and reciprocity proofs is the same for all the other parameters also. I will not explain for remaining parameters. Just you can మీరు అసైన్మెంట్గా కంప్లీట్ చేసేసండి ఈ వర్క్. సిమ్మెట్రీ రెసిప్రొసిటీ ఏదైతే ఇక్కడ మెథడ్ నేను ఫాలో అయ్యానో ప్రూఫ్స్కి, ఇదే మెథడ్ అన్ని నెట్వర్క్స్కి, అంటే హెచ్ పారామీటర్స్ కావచ్చు, ఏబిసిడి కావచ్చు, జీ పారామీటర్స్ కావచ్చు, అన్ని పారామీటర్స్కి సేమ్ మెథడ్ని మీరు ఫాలో అయ్యి కంప్లీట్ చేయండి ఆ వర్క్. ఓకే, ఓకే. And next I will take one problem. Okay, So find the Z parameters for a given network, okay. So this is ZA and ZB, ZC, okay. This is our network, okay. For this network I need to evaluate Z parameters, okay. Now solution. So first I will take Z parameters, that is V1 equals to Z11 into I1 plus Z12 into I2, and V2 equals to Z21 into I1 plus Z22 into I2. So these are the two equations which are related to Z parameters, right? Now already we have here V1 variable, so that you can indicate here I1 current. Already we have here V2, so that you can indicate I2 amount of current, right? So in order to evaluate Z parameters in the sense what? Z11, Z12, Z21 and Z22. So these four parameters you need to evaluate for a given circuit, right? So in order to find out Z11, Z21, you need to make I2 equals to 0. If I make I2 equal to 0, I can evaluate Z11 parameter, Z21 parameter. In a similar context, if I make I1 equals to 0, I can able to find out Z12 to Z12, Z22 parameter, right? So in that way, in that case, I am taking first I2 equals to 0. That means I2 should be open circuit. Otherwise, port 2 should be open circuit, right? Port 2 should be open circuit. So in the next case, I1 equals 0. That means the port 1 should be open circuit. Should be open circuit. Clear? Okay. Now, so for example, so if I make I2 equals 0, if I make I2 equals to 0, that means this is completely open circuit. If it is open circuit only, I2 will make it as 0. Otherwise, we cannot make it as 0, right? So by considering port 2 as open circuit, we will make I2 equals to 0. Now you can apply KVL for this entire loop. So by KVL minus V1 plus this I1 into voltage drop across this particular resistance, right? So I1 into ZA, I1 into ZA, and voltage drop across this particular ZC element. If you observe this ZC element, so the current can be flowing through this ZC equals to I1 plus I2. At this we have I1 amount of current, at this we have I2 amount of current. Now here I1 plus I2 amount of current flowing through this particular ZC. So that I am taking here uh, ZC into I1 plus I2. But according to our assumption, I2 equals 0. Because of this open circuit, I2 will get 0 amperes current. So that this will make it as 0. Now you can conclude that which is equals to 0. Algebraic sum of voltage in a particular loop equals to 0. Now you will get V1 equals to, okay, V1 equals to I1 into ZA plus I1 into ZC. So if you take I1 as a common factor, then you will get ZA plus ZC. So now what you will get? V1 by I1 equals to ZA plus ZC. V1 by I1 is nothing but what? Z11. That means at port 1 voltage variable and at port 1 I1 variable. So the ratio between voltage and current will give the impedance. So that impedance which are related to port 1. So that means what? Z11 equals to ZA plus ZC. This is the first Z parameter, right? This is the first Z parameters. Okay. In the similar way, okay, the similar way you can calculate. So this is I2 equals to 0 condition. So you can evaluate Z21 also, right? You can evaluate by making I2 equal 0, you can evaluate Z21 also. Now in the previous case, so I'm applying the loop at port 1. That means in this loop I'm applying KVL. Now in this loop also you can apply KVL. By KVL, by KVL. So first you can check this loop. This is the V2 voltage and this I2 into JB voltage drop here. Here I1 plus I2 into ZC voltage drop here, right? So that I am taking minus V2 plus I2 into ZB. Okay, that means this one. Across this resistance, the voltage drop equals what? I2 into ZB. Next, I1 plus I2 into ZC, which is equals to 0. But according to our assumption, I2 will become 0. Then what you will get? Minus V2 plus I1 into ZC. I1 into ZC, which is equals to 0. Now V2 equals to I1 into ZC. Now V2 by I1 equals to ZC. But V2 by I1 equals to what? Z21. This is output and this one is input. Okay. So this is equals to ZC. Okay. So this is about Z21 value. So by making this I2 equals 0, we are getting two parameters. One is Z11 equals to what? ZA plus ZC, and Z21 equals to what? ZC. These are the two things. In a similar way, you can find out for this also. Okay, I1 equals 0, port 1 should be open circuit. Here you need to apply. That means now here I1 equals to 0. In the second condition, I1 equals 0. That means port 1 should be open circuit. Okay. So now you can erase this thing, and you can erase this one and this one also. Okay. Now you can take loop at port 2. Okay, by KVL, minus V2 plus I2 into ZB. Okay, plus I1 plus I2, I1 plus I2 into ZC, which is equal 0. But according to our assumption, this is open circuited, so that I1 equals to 0, right? So now this I1 should be equals to 0. Then you will get a minus V2 plus I2 into ZB plus I2 into ZC equals to 0, right? Now I2 into ZB plus ZC equals to V2, right? So now from this V2 by I2, V2 by I2 equals to ZB plus ZC. But V2 by I2 equals to what? Z22, right? Z22 equals to ZB plus ZC, right? In the similar way, you can apply for this loop KVL, then you will get Z12 also, right? So now here I am taking I1 equals to 0 for Z12 evaluation. So by KVL, so minus V1 plus I1 into ZA plus I1 plus I2 into ZC equals 0, but I1 equals to 0 according to our assumption. So here V1 voltage, I1 into ZA resistance, I1 plus I2 into ZC, right? Same thing I will consider here. By making I1 0, so minus V1 plus I2 into ZC equals to 0. From this V1 equals to I2 into ZC, and V1 by I2 equals to ZC. And now, so this V1 by I2 is nothing but what? Z12. So V1 by I2 equals to ZC. So now from this Z12 equals to what? ZC. Right? Now you can observe. So here Z11 equals what? ZA plus ZC. Z22 equals what? ZB plus ZC. And Z21 equals what? ZC. And Z12 equals what? ZC. So for a given this particular network, okay, the Z parameters equals to Z11, Z12, Z21, Z22, which is equals to Z11 equals what? ZA plus ZC. ZA plus ZC. What about Z12? ZC. Z21? ZC. What about Z22? ZB plus ZC. This is your resultant matrix, right? So that means Z11 equals what? ZA plus Z. If I want to find, so this is derivation, right? సో ఇన్ అవర్ అంటే మీకు ఎంట్రన్స్ ఎగ్జామ్లో మీకు క్వశ్చన్ ఇలా ప్రొవైడ్ చేసినప్పుడు Z1 అంటే మీకు ఎగ్జాక్ట్ ఈ ప్యాటర్న్ కనుక ఎగ్జిస్ట్ అయితే Z11 ఈక్వల్స్ టు వాట్? ZA ప్లస్ ZC. సో ఈ రెసిస్టెన్స్ని ఈ రెసిస్టెన్స్ని యాడ్ చేస్తే సరిపోతుంది Z11. ఓకే, Z22 అంటే ఎలా ఫైండ్ అవుట్ చేస్తారు? ZBని ZCని యాడ్ చేస్తే సరిపోతుంది. ఓకే, what about Z12, Z21? Z12, Z21 అంటే transfer impedance from port 1 to port 2 and port 2 to port 1, right? So that is what ZC and ZC. ఇక్కడ అబ్జర్వ్ చేస్తే మీరు పోర్ట్ 1 నుంచి వెళ్ళి పోర్ట్ 2కి ట్రాన్స్ఫర్ అయ్యే ఇంపెడెన్స్ ఏంటి? ZC. పోర్ట్ 2 నుంచి వెళ్ళి పోర్ట్ 1కి ట్రాన్స్ఫర్ అయ్యే ఇంపెడెన్స్ ఏంటి? ZC ఉంది, రైట్? పోర్ట్ 1 దగ్గర మీరు అబ్జర్వ్ చేస్తే దట్ ఈస్ ద కాంబినేషన్ ఆఫ్ దీస్ టూ రెసిస్టెన్స్. పోర్ట్ 2 దగ్గర మీరు అబ్జర్వ్ చేస్తే దట్ ఈస్ ద కాంబినేషన్ ఆఫ్ దీస్ టూ రెసిస్టెన్సెస్, రైట్? దట్ ఈస్ ద కన్క్లూజన్, రైట్? మీకు ఎలాగైనా ప్రొవైడ్ చేయొచ్చు. మీకు Z11, Z12, Z21, Z22 వాల్యూస్ ఇచ్చేసి ZA, ZB, ZC వాల్యూస్ అడగచ్చు. లేదు అంటే దే ఆర్ ప్రొవైడింగ్ ZA, ZB, దట్ మీన్స్ ZA, ZB, ZC వాల్యూస్ అండ్ దే కెన్ ఆస్క్ అబౌట్ దిస్ Z11, Z12, Z21, Z22 వాల్యూస్. సో మీరు ఎలాగైనా కాదు, బట్ ఇది ప్యూర్లీ టీ నెట్వర్క్కి మాత్రమే అప్లికేబుల్. దిస్ ఈజ్ లైక్ టీ ఫార్మేట్, రైట్? దిస్ ఈజ్ లైక్ టీ నెట్వర్క్, దిస్ ఈజ్ గ్రౌండ్. ఓకే, ఈ టీ ఫార్మేట్లో మీకు ప్రొవైడ్ చేసినప్పుడే జెడ్ పారామీటర్స్ అనేది డైరెక్ట్గా అప్లై చేస్తారు. దీన్ని టీ లేదా మీరు వై నెట్వర్క్ కూడా కన్స్ట్రక్ట్ చేయొచ్చు. ఓకే, వై నెట్వర్క్ అదర్వైజ్ స్టార్ నెట్వర్క్ ఆల్సో. ఓకే, ఈ ఎంటైర్ ప్యాటర్న్ని మీరు జస్ట్ దీన్ని ఇట్లా బెండ్ చేస్తే మీకు అది వై నెట్వర్క్లో ఫామ్ అవుతుంది. వీ కెన్ కాల్ ఇట్ అ స్టార్ నెట్వర్క్ ఆల్సో. ఫర్ ఎగ్జాంపుల్ మీకు డెల్టా నెట్వర్క్ ప్రొవైడ్ చేశారు. ఓకే, దిస్ ఈజ్ డెల్టా నెట్వర్క్. ఈ డెల్టా నెట్వర్క్ ఇచ్చేసి మీకు జెడ్ పారామీటర్స్ ఫైండ్ అవుట్ చేయమని అడిగినాడు అనుకోండి. అప్పుడు మీరు ఏం చేస్తారు? ఈ డెల్టా నెట్వర్క్ని మీరు వై నెట్వర్క్లోకి కన్వర్ట్ చేయండి. వై నెట్వర్క్ ఇన్ ద సెన్స్ వాట్? టీ నెట్వర్క్. ఈ టీ నెట్వర్క్కి మీరు డైరెక్ట్ జెడ్ పారామీటర్స్ అప్లై చేయండి, సరిపోతుంది, రైట్? So this is one problem which are related to Z parameters. And now the second problem is and the second problem. So this is about this is 1 ohm, 2 ohm, 5 ohm. So find the Z parameters. Find the Z parameters. So Z parameters, Z equals to Z11, Z12, Z21, Z22. So this is your Z parameter according to our formula. So you can assume this as ZA, you can assume this as ZB, and you can assume this as ZC. Formula is what? ZA plus ZC, and this is ZC, and this is ZC, and ZB plus ZC. So now Z equals to ZA plus C, that means 1 ohm plus 5 ohm, 6, and this is ZC, that is 5 ohm, and ZC 5 ohm. This ZB plus ZC means this 2 plus 5, that is 7. This is your Z parameter for a given T network. But in some questions, in gate point of view, they are not providing ohms, they are providing mohs. In that context, the same problem, if I am taking like this is 1 mho, and this is 2 mho, and this is 5 mho. Now you can calculate the Z parameters for this. So in that context, first you can convert these mohs into ohms format. Okay, that means mohs to ఓమ్ కన్వర్షన్. ఓకే, ఎలా కన్వర్ట్ చేస్తారు? ఇన్వర్స్ తీసుకుంటే సరిపోతుంది, 1/1. ఓకే, సో 1/1 విల్ మేక్ ఇట్ యాజ్ ohms, and this will make it as 1/2 ohms, and this will be make it as 1/5 ohms. Now you can add in the first parameter, Z parameter, this one plus this one, right? So that means 1 plus 1/5. 1/1 plus 1/5 is nothing but 1 plus 1/5 only. When coming to this particular thing, so we will get 1/5. Here also we will get 1/5. Next 1/2 plus 1/5. If you simplify this, you will get the Z parameters. So you can verify the problem carefully whether they are providing ohms or whether they are providing mohs. Okay, that is very very important. Conductance ఇచ్చాడా, రెసిస్టెన్స్ ఇచ్చాడా అనేది ప్రాపర్గా చెక్ చేసుకోండి. ఒకవేళ కండక్టెన్స్ ఐ మీన్ అంటే మోస్ ఫార్మాట్‌లో ఇస్తే, కండక్టెన్స్ ఫార్మాట్‌లో ఇస్తే గనక, దాన్ని మీరు రెసిస్టెన్స్ ఫార్మాట్‌లోకి కన్వర్ట్ చేసుకోవాల్సి ఉంటుంది. డైరెక్ట్‌గా అప్లై చేయడం కాదు. అది ప్రాపర్‌గా చెక్ చేసుకున్నాకే అప్లై చేయండి. అండ్ ద నెక్స్ట్ ప్రాబ్లమ్, ఫర్ ఎగ్జాంపుల్, I have the network like this. Find the Z parameters. Third problem. Find the Z parameters. Okay. So this is your network. Okay. This is your network. This is 1 ohm, 1 ohm, and 1 ohm. Okay. Now you can find the Z parameter. Already you know the star to delta conversion and delta to star conversion. Okay. That means delta equals to 3y. That is the formula, right? Already I have a delta network, but I need to evaluate star network. That means y network. So that y equals what? Delta by 3. That means what? This network is converted in this format. So this is 1 by 3 and 1 by 3, 1 by 3. Why? Because delta equals to what? 1 ohm. Then you will get 1 by 3 ohms. So now you can form it as like this T network. So this is 1 by 3 ohm, and this is 1 by 3 ohm, and this is 1 by 3. Now you can find out the Z parameters, that equals to 1 by 3 plus 1 by 3, right? And this is 1 by 3, and this is 1 by 3, and again this 1 by 3 plus 1. This is your Z parameter. And in the next case, I will take, the problem is like this. So this is our problem. So I am taking one more, one more, one more. This is also delta network only. Okay, you can redraw the circuit like this. Okay, but because these two are connected one particular terminal, right? These two nodes are one single node. So like that I will take here. Okay, then this is form a delta network or not? Now you can convert it into Y format. Okay, how you convert? Just you can make it as so this is your Y format. But if you observe this, so this delta network having 1 mho, not 1 ohm. That is very important. Already Y conversion is what? Y equals delta by 3. 1 by 3 mohs here, not ohms. But in order to find out Z parameters, first you need to convert it into ohms format. 1 by 3 ohms means 1 by 1 by 3 ohms. That means what? You will get 3 ohms, right? If I want to find out ohms format, you will get 3 ohms. Now you can take 3 ohms, 3 ohms, and 3 ohms. Now you can make it as a T network. This is 3 ohms, 3 ohms, and 3 ohms. Now the Z parameters equals what? 3 plus 3, 3, 3, 3 plus 3. This is your Z parameter. These are the some of the previous gate problems. Okay. Now you can take any reference book, otherwise any previous year's gate questions, otherwise any previous year's IESE question. This you can solve Z parameters related problems. Alright. So this is about Z parameters. In the next session, I will explain about Y parameters. Right. Thank you.